Okay, so in this lesson we're going to be going over properties of rational exponents. The properties of integer exponents that we've previously learned can also be applied to rational exponents. Rational meaning fractions. So what we want to do is we want to simplify expressions with rational exponents. We want to rewrite all radicals in exponential form, use the exponent rules to simplify the expression, and then write our answers as a radical in simplest form, rationalize if needed. So on the first one I want to, because I have two of the same base that's being multiplied together, I want to add my exponents together. So I really can rewrite this as x to the 1/3 plus 4/3, which gives me 5/3. And then I want to write it as a radical in simplest form. So remember, the number on the bottom of the fraction goes on the outside of my radical in the index. And then I'm going to have x to the 5th on the inside. Just kidding, that's not my final answer. So on this one, I want to, what we did yesterday, I want to simplify it. So I can take out, because if I think about this, x to the 5th is really 5x's. So I can take out a group of 3 x's. So that can go on the outside. And then I still have 2 x's left over on the inside. So this x on the outside represents the group that I took out. And then squared for the 2 that are still on the inside. So same thing on the next one. I want to do 1/4 plus 3/2. If I can't add that, remember I can add on my fraction. Add on my calculator. So I can do 1/4 plus 3/2. And then I go math. So there's a math button right here. And then my first choice is fraction. So I press enter, enter, which gives me 7/4. So I can rewrite this. It's going to be the 4th root of p to the 7, which I can pull out a group of 4. So that's 1p on the outside. And then 7 minus 4 gives me p cubed on the inside. Okay. Next one, when I have a fraction, or when I have a base over a base, I want to subtract my exponents. So on this one, I'm going to have 5/2 minus 7/4. So I can do that on my calculator again. And I'm going to go math, enter, enter, which gives me 3/4. And then I'm going to rewrite it as a radical. So the 4 goes on the outside because it's the bottom number of the fraction, and then 3 is my exponent. Here I can't simplify any further, so this one is my final answer. When I have a fraction to a fraction, I multiply. So 1/3 times 5/2 gives me 5/6. So I can rewrite. 6 goes in my index. 5 is my exponent on the a. Can't simplify, so that's my final answer here. Same thing with 32. I want to multiply my exponents, so that's going to give me 32 to the 1/2 times 1/2, which is 32 to the 1/4, which is the 4th root of 32. So if I factor tree 32, I get 2, 16, 2, 8, 2, and 2. I can pull, because 8 is 2 and 4. There we go. So I have a group of 4 2's that I can pull out. So that's going to be this 2 on the outside. And then I have a 4th root. I have a leftover 2 right here. So that goes inside my radical. Next one, I want to distribute in. So I'm going to have 8 to the 2/3. And then I have 2x to the 2 times 2/3. So I'm going to rewrite. I have 8 to the 2/3 still, times x to the 4/3. 8 to the 2/3 I can do by hand, or I can use my calculator because it never told me to do it by hand. So 8, and then I can raise my exponent to the 2 divided by 3, which gives me 4. And then for my x, the 3 goes on the index, and then it's x to the 4th. I can subtract 3 from that, so I can rewrite that. I have 4 and x on the outside from that group of 4, x to the 4th. And then I still have 1 left over because 4 minus 3 is 1. So that x stays on the inside. On this one, it is a little tricky to see, but that is a negative 1/2. So remember, negative fractions I can rewrite as the bottom of a fraction. So I really have 1 over 100 to the 1/2, or 1 over the square root of 100, and the square root of 100 is 10. Ooh, I wrote over the next one. That one is 16 to the 2/3 times 16 to the negative 1/3. So this one, I add the exponents, or in this instance, I subtract because it was a negative 1/3. So 2/3 minus 1/3 is 1/3. So I really have the cube root of 16. If I factor tree 16, I get 2, 8, 2 and 4, 2 and 2. I have one group of 2's for one group of 3 2's, so that comes to outside. And then I have a 2 that stays on the inside. Okay, next one I have negative 2/16 to the negative 1/3. So I can rewrite this as 1 over negative 2/16. I'm going to leave this in parentheses, and then I'm going to raise it to the 1/3. I can rewrite this as 1 over the cube root of negative 2/16. I can't remember if 2/16 is a perfect cube. So I'm going to go math. Choice 4 is my cube root, and then I'm going to type in 2/16. Oh, it is a perfect cube root. So I get equals negative 1/6. I can move the negative to the top. I can move it out front of my fraction. Typically, we don't leave the negatives on the bottom, though. Next one I have is 112 over 7 to the 1/4 power. Sorry, negative 1/4 power. So because this fraction, or this is a fraction with a negative exponent, I flip the fraction, and then I raise it to the 1/4 power, because I make the fraction positive now. So then I can rewrite this. This is the 4th root of 7 over 112. I want to see if I can simplify 7 and 112, just in general. So I'm going to type in 7 divided by 112, and then I'm going to turn it back into a fraction, which it does. It simplifies nicely into 1/16. So I have the 4th root of 1 over 16, which I can go math, choice 5, type in 4 for my index, and 1 divided by 16 for my fraction. It gives me a decimal, which gives me 1/2 as my final answer. This next one, I want to turn it back into fractions so I can add them together. So I'm going to have v to the 1/3, times v to the 1/2. So I want to add the exponents together. Oops, I am no good with this. So 1/3 plus 1/2 gives me 5/6. Then 6 is my index, and 5 is my exponent. Same thing on the next one. I have r to the 3/4 times r to the 1/2. So I'm really doing 3/4 plus 1/2. Turn it back into a fraction. Gives me r to the 5/4. So I have the 4th root of r to the 5th, which I can pull out because the 5 is larger than the 4. I have an r on the outside, and then 5 minus 4 leaves me with 1, so I have 1 r left on my inside. next thing I have is simplifying radical expressions. Same thing as before. So I can rewrite this as 4 to the 1 power divided by 4 to the 1/3. Because it's a fraction, I can subtract my exponents. So I have 4 to the 1 minus 1/3, which gives me 4 to the 2/3. I can rewrite this as the cube root of 4 squared. I'm going to rewrite 4 squared as 16. And I want to simplify this. So remember my factor tree for 16 breaks down to 4 2's. So I can pull out a group of the 3. And that goes on the outside. Then I have the cube root, and I have that leftover 2 on the inside. Same thing on this next fraction. I have 7 to the 3/2 over 7 to the 1/2, which I can rewrite as 7 to the 3/2 minus 1/2. 3/2 minus 1/2 is just 1. So 7 to the first power is just 7. On the next one, I can, if I think about how many total x's I have in here, I'm going to write them out. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm looking for groups of 4. So I have 1 group, 2 groups, leftovers. So I'm going to have x squared to represent the 2 groups that I circled on the outside. Then I have the 4th root, and I have x squared to represent the 2 that are left over on the inside. On the next one, I want to see if I can simplify this. So 25 breaks down to 5 and 5. I can't do anything with that. And my m squared I can't do anything with. So this stays the 4th root of 25 m squared. Nothing to simplify here. On the next one, I'm looking for the cube root of -72, 8 to the 9th, b squared. So I'm going to do my factor tree of 72. 2 and 36, 2 and 18, 2 and 9, 3 and 3. So I have a group of 3 2's. I'm going to pull that out along with the negative. Then I have 9 divided by 3. We learned that yesterday. That's going to give me a cubed. And then I can't do anything with that b. So I'm going to leave that under the radical with the 3. And then I had these 2 leftover 3's. So 9, because 3 times 3 is 9. And then b squared. Same thing over here. So I have my 81, which breaks down to 9 and 9, 3 and 3, 3 and 3. So I have a group of 4 3's. I can pull that out. With my m's, I can pull out 8 m's, which are going to turn into 2 groups of 4. So that gives me m squared. And I can pull out 5 n's. So remember, since I have an even number for my radical, this is going to turn this odd one into an absolute value. And then I said I had 3 m's left over. My last ones, I want to divide my coefficients and then use the quotient rule and then simplify the resulting radical. So on number 1, I can divide 12 divided by 2. That's going to give me 6. And then I can turn this into one giant radical. I can turn it into 160 divided by 5, which I am not quite sure of. My calculator gives me 32. So I have 6 times the square root of 32. If I factor tree 32, I'm looking for groups of 2 because it's a regular radical. I have 2 pairs of 2, so I have 6 times 2 times 2, and then I have a leftover 2 on the inside. 6 times 2 is 12, times 2 is 24. So my answer here is 24 square root of 2. Okay, same thing on number 2. 36 divided by 9 is 4. Then I have the fourth root of 1,250 divided by 2. So 4 times the fourth root, and I want to actually divide 1250 by 2. Gives me 625. I'm going to factor tree 625. So this gives me 5 and 125. And then 125 gives me 5 and 25. And 25 gives me 5 and 5. So I have a group of 4 5s. So this results in 4 times 5, which is just 20. Okay, next one, I'm just going to start off making it one giant fraction. So I have x cubed, y to the 9th, divided by x squared, y to the 5th. I want to simplify these by subtracting my exponents. So x cubed minus x squared is just going to leave me with x. Y to the 9th minus y to the 5th is going to give me y to the 4th. I can't do anything with that x, so it's going to stay under the radical. But I can take 4 and divide by the index here, which is 2, which is going to give me y squared. That's my final answer here. Number 4, 28 divided by 4 is 7. Then I can make this one giant radical. So I have negative 16m to the 6 over 2m. I want to rewrite that as 1, or I want to actually divide on the inside of that. So negative 16 divided by 2 is negative 8. M to the 6th divided by m is m to the 5th. I can take the cube root of negative 8, that's going to be negative 2. And then I can pull out 3 m's, which are going to turn into 1m on the outside. And I'm left with 2 on the inside. Then I just want to take that 7 and multiply by the negative 2, which gives me negative 14 times m times the cube root of m squared. Okay. On the next one I have 48 divided by 16. That can simplify to the square root of 3. So nothing to simplify beyond that. Next one, I have the cube root of 40 over 27. I can't simplify this fraction as it is, but I can split this one up into 2 individual radicals. So I want to separately check my factor trees of 40 and 27. So 40 breaks into 5 and 8, which is 2 and 4, 2 and 2. I have a group of 2's. So that can come out to the outside, and then I have a 5 left over on the inside. And then I want to do the same thing for 27, which gives me 3 and 9, 3 and 3. I have a group of 3's, so I have a 3 on the bottom of this fraction.